This video is supported by CuriosityStream. Last week I talked about some of the most Earth-like exoplanets that we've found, and while it's cool that we found them, the bummer, of course, is that we'll probably never actually get to go see them. So instead I talked about some of the next generation space telescope technology that's going to allow us to study them from afar. Yeah, you know all those cool science fiction movies where we just study things from afar? Yeah, I don't either. We're humans, we want to go, we want to see things, we want to explore, and we can't. That sucks, at least with current technology. Of course, there's no shortage of ideas to get around current technology and actually make it possible to go see these other worlds. Some ideas are more plausible than others. So this video is going to kind of piggyback off of last week's video and talk about some alternative drive systems that might actually make our sci-fi dreams a reality. Chemical rockets have been our ride to space since the 1950s. It's proven technology, and we understand it really well. When I say we, of course, I mean rocket scientists and engineers and stuff. And random nerds on YouTube. And they work because chemical reactions pack a punch. The Saturn V rocket that took astronauts to the moon got 7.5 million pounds of thrust out of its 5 first-stage engines. The most powerful rocket in current use, the SpaceX Falcon Heavy, produces about 5 million pounds of thrust. The Earth is a jealous mistress, one who does not easily give up her children. To escape the surly bonds of Earth, you need a lot of power. Thing is, once you get up to orbital speed out in outer space, all that power almost becomes a problem. Navigating in a microgravity vacuum is less like flying a plane and more like throwing darts. You burn the engines just a few seconds at a time and get up to the speed and the trajectory that you need to go on, and then you just kind of glide the rest of the way. You could go a lot faster if you could accelerate for longer, but chemical rockets tend to burn through their propellant pretty quickly. That propellant, by the way, is super heavy, which adds mass, which means you need more energy to accelerate that mass, which means you need more propellant, which adds more mass. This is the tyranny of the rocket equation. And this is why SpaceX plans to refuel in orbit before it heads off to Mars with the Starship, because it's actually going to burn through some of its propellant just getting up into orbit. And I've heard different estimates as to how many launches are going to need to refuel it in orbit, all the way up to 6. You might have noticed this is not how space travel is portrayed in sci-fi movies. Most of them anyway. It's usually more like flying through the air, just rockets burning the whole way. And that's usually just a flight of fancy on the part of the filmmakers, but rocket designers would love to do that too. The thing is, low constant acceleration can actually push a spacecraft a lot faster over time than chemical rocket burns can. So any technology that could provide even a tiny amount of constant acceleration with lighter propellant would be game-changing. Take ion thrusters, for example. I've talked about that here on this channel before, but they produce acceleration by launching ions, charged ions, out the back of the engine. Now that's a tiny, tiny amount of mass that produces a tiny amount of thrust, but again, constant acceleration adds up. As you know, every action produces an equal and opposite reaction, the old Newton's third law. Chemical rockets get their action from releasing that heavy propellant at explosive high velocity out the back, which creates a reaction toward the pointy end. And ion thrusters work the same way, except the propellant is tiny charged xenon atoms, which obviously carry very little force, but these are flung out with powerful electromagnetic fields at 90,000 miles an hour, and it does it billions of times per second. Why xenon? Well, Scott Manley did a great video about it that I'll link up down below, but first and foremost, xenon is a noble gas, which means that it won't react with any of the materials on the engine. And of the noble gases, xenon has one of the highest atomic masses, which gives you just a little bit more force out of it. And finally, ion engines work by knocking electrons off of atoms by bombarding it with electricity. And the more electrons that you have on an atom, like a xenon atom has, the more opportunities there are to knock an electron free, the less energy it takes to create the ion. So the propellant is lighter for ion drives, but it does still require a lot of electricity, which if you're floating around the inner solar system like the Dawn spacecraft, you can get plenty of it from PV panels. But venture out into the outer solar system or beyond, you're going to have to carry some kind of power source with you, which is going to add mass. A future technology might make it possible to power a spacecraft with a laser. Some kind of fusion technology might make it so you could collect gas from interstellar space. There might only be 1 atom per cubic meter of space, but you could take that and make fusion energy with it, but still, an ion drive would have that xenon in there, and that would eventually run out. The ultimate solution to long-distance space travel would be a rocket that doesn't have to carry propellant mass. A rocket with this engine would defy the tyranny of the rocket equation. It would also defy Newton's third law, producing an action without an equal and opposite reaction. Which is why they call these kinds of theoretical engines a reactionless drive. Serious scientists pretty much roll their eyes at this concept. It's basically the holy grail of rocket science, and it's considered impossible by most people, but it has not stopped people from trying. First on the list is the Dean drive. The Dean drive is the brainchild of Norman L. Dean, who filed patents for this back in the 1950s, but they were incomplete, so if you wanted to make a Dean drive based off of the patents, you wouldn't be able to do so, which makes it sound super legit. Dean got some early publicity when his claims were investigated by famous science fiction editor John W. Campbell of Astounding Magazine. John W. Campbell's kind of a legend in sci-fi circles. Unfortunately, he was also kind of a fan of segregation and once called slavery a useful educational system. So yeah, for a futurist, he was pretty stuck in the past. He was also apparently a sucker because he claimed the Dean drive worked. In a private demonstration, Dean claimed that he saw the drive actually reduce its own weight on a scale and thought that Dean had created a way around Newton's laws in some way, and he thought that it was going to revolutionize travel both on Earth and off. The basic idea behind the Dean drive is that it would harness the centrifugal force created by spinning weights. Now normally this would create a balanced back and forth motion, action-reaction and whatnot. But Dean claimed that through some kind of complicated mechanism, he could basically cut out the reaction part. So you would get an action in one direction without a reaction, meaning you would get thrust in that direction. And he explained this by phrasing it in terms of inertial reference frame. So the reaction did happen, it just happened in a different frame than the one that we're in, somehow. So yeah, since the reaction is taken out of this frame, it creates thrust, supposedly. Now this is nowhere near the only idea involving gyroscopes and spinning weights and stuff like that. In fact, back in the 90s, NASA actually had a program where people would submit ideas for advanced propulsion drives, and they got so many involving gyroscopes and oscillating weights and whatnot that they had to produce an internal memo with guidelines on how to deal with it. It was titled Responding to Mechanical Anti-Gravity, and one of the standout lines was, quote, "About a third of amateur requests, 9% of all submissions displayed paranoia or delusions of grandeur." NASA throwing some shade. And they went on to caution sensitivity when dealing with those submissions, but also to, not waste NASA's time. Now the Dean drive does still have its defenders, but it has been pretty thoroughly debunked. Really, all you need is a pendulum. The notion that Dean's drive produces is actually called slipstick motion. The ground itself basically serves as the reaction mass, so it moves forward by friction, basically. Put the drive on a pendulum where it's not in touch with the ground, and the effect tends to go away. Obviously, a drive that only works when it's in contact with the ground is not very useful in a space situation. In general, there's nothing magical about gyroscopic drives. They work off the conservation of angular momentum. It's basically torque being misidentified. The Mega Drive was proposed in 1993 by Dr. James Woodward of the University of California, and it takes advantage of a phenomenon known as the Mach effect. Hence the name Mach effect gravity assist drive, or Mega Drive.
That it's not just a clever name.
This idea is sort of similar to the Dean drive in that it steals momentum from an action that should be producing a reaction but doesn't. But in the Mega Drive, the back and forth motion is created by piezoelectric discs, which charge on one end of the motion and discharge on the other end of the motion. So according to Woodward, when it's charged, there's more electrons in there, which adds just a tiny bit of mass. And then when it discharges on the other end, it releases that mass, meaning that it actually produces a little bit of momentum in one direction. Haha, clever, but does it work? Scientists are skeptical, and even if it does work, it would have to be scaled up massively because, well, electrons don't weigh very much. But tests so far have actually been positive. Last we heard was in 2019, they were able to assure NASA that they got the effects of vibration out of their measurements because the effect is so slight that any kind of aberration has to be counted in. But obviously fingers are crossed on this one. We'll have to see some more tests to figure it out. The M drive is something I've covered before. You can check it out here if you want to get the deep dive, but here's a quick primer on it. The M drive is basically a cone with microwaves bouncing around inside of it, and it's a closed cone, so there's nothing actually going out the back of this thing. And this should do nothing. The microwave should just bounce off the inside of the thing, off of the walls producing a force equal to that of the microwaves bouncing against it, action, reaction, and whatnot. It's kind of like saying you can move a car forward by pushing on the dashboard. But some very smart people have been able to measure a net thrust in one direction. They claim that it actually is interacting with the zero-point energy in a quantum vacuum. But, of course, other smart people have pointed out that that might just be attributable to thermal heating, some gravitational abnormalities, or even just the movement of air in the room. So it's still very much debated. But interestingly, Dr. Woodward does have a different opinion on how this works. He thinks it actually might use the Mach effect that we were just talking about to push against the gravitational potential of the universe. Is the gravity potential of the universe an actual thing? No, I'm asking. I have no idea. I kind of feel like we're never really going to know the answer about the M drive until we can just get one in space and see if it gains momentum over time. I don't know, maybe Starship can just drop one off on the way to the moon or something. The helical engine is perhaps the newest concept that I've been talking about today, and it works on a similar principle as the mega drive, only this one gets relativistic. The idea was theorized by David Burns, a PhD in electrical engineering at NASA, and before you put him in the wackadoodle pile, he did have this to say about his idea. Quote, "If someone says it doesn't work, I'll be the first to say it was worth a shot." Probably a good attitude. So instead of affecting the mass of oscillating disks by adding and removing electrons like the mega drive, this one adds mass by spinning particles up at relativistic speeds. According to Einstein, objects gain mass as they get closer to the speed of light. So Burns' idea is to put a particle accelerator and accelerate the particles through a helix from one side of the engine to the other. As they speed through the helix, they gain momentum and mass so that they weigh more on one side than they do on the other. Add to this a well-timed oscillation of the helix and you can get a very small one-directional thrust. He proposed that a 12-meter ring containing the accelerator helix would suck up about 165 megawatts of power and produce about 1 newton of thrust. How much is 1 newton of thrust? About the same amount of force as this apple against my hand. Not staggering, but not nothing either. Again, that 1 newton force would add up over time. With unlimited power, you could get to Alpha Centauri in 90 years. Of course, power is not unlimited, and you're talking about running a small Large Hadron Collider 24 hours a day. Wouldn't that just be a small Hadron Collider? So yeah, that's kind of an issue. And that's if the thing works at all, which is questionable. Astrophysicist Ethan Siegel says in his blog, if Burns had properly accounted for the total momentum of the box plus ring system, he would have noted that the total momentum never changes. Yeah, treating the ring as an independent system is problematic because when you factor in all the forces in the box ring system, they kind of cancel each other out. And Dr. Brian Koberlin, in an article for Universe Today, pointed out that time dilation and length contraction also add up together to balance out the whole action-reaction thing. So sprinkling a light frosting of relativity on a Dean drive, unfortunately, doesn't make it not a Dean drive. And last but not least is the Alcubierre warp drive. Again, I've talked about this one before, linked down in the description, but this one is quite a bit different from the others in that it's not trying to skirt the laws of science, it's working on proven science. This was conceptualized by Miguel Alcubierre in 1994, and it quickly gained an interest amongst physicists that were fond of the warp drive concept, including Harold Sonny White, formerly of NASA's EagleWorks lab. It works by expanding and contracting space-time. Effectively, the spacecraft would create a bubble that shrinks space-time ahead of it and stretches space-time behind it. So it's kind of a cheat around the speed of light because it's not actually passing through space, it's just warping the space around it. Alcubierre expected that a craft like this could reach velocities way faster than light by repeatedly shrinking the space in front of it, which sounds great. There are a few hang-ups. To do this requires access to exotic matter. What is exotic matter? Well, exotic matter is made up of negative mass, meaning if you had 1 pound of negative matter and put it on a scale, the scale would say -1 pound. I'm making that sound ridiculous because it is. But the math of physics leaves room for negative mass and white holes and time travel. So it could possibly exist out there naturally, or we might actually be able to make it in a lab. Either way, it's going to need a lot of this stuff, like, according to his original paper, more mass than exists in the observable universe. Sonny White would later propose shaping the warp bubble like a torus, which actually reduced the amount of mass needed from, the size of the universe down to something about the size of the Voyager spacecraft. That's a tiny jump in mass there. But still, it's the mass of the Voyager spacecraft in a material that doesn't exist. A 2019 paper by Joseph Agnew at the University of Alabama did make some advancements in this idea, but we really haven't seen much else about this in terms of actual progress on the Alcubierre drive. Probably because of the whole needing matter that doesn't actually exist thing. Now, some have proposed that if there was a fourth spatial dimension, that you might be able to use that to expand and contract the space-time around the spacecraft. That would solve the exotic matter problem. Other proposals suggest that a warp ship wouldn't actually have to expand the space behind it. It would only need to worry about contracting the space in front of it, and the space behind would snap back into place automatically. This would cut down on the amount of power needed because you're only doing half of it. Now, another interesting theory in Agnew's paper is that you could replace the exotic matter with really powerful electromagnetic field emitters, but it should be said that this idea is so out there they actually call it semi-exotic. But it's nice to have alternatives. So this is probably not what you want to hear. I know. You probably clicked on this video thinking, oh, here's going to be some alternative propulsion devices that are going to get us to the stars and save us and all that. And here I am just, throwing a wet towel on your head. I'm the worst. But the fact of the matter is, interstellar travel on any kind of useful time frame anyway, just might be impossible. And pursuing technologies like this might just be a total waste of time. But then it might not be. Fans of this channel are probably more than familiar with Arthur C. Clarke's third law, which states that any sufficiently advanced technology is indistinguishable from magic. Well, getting to the stars and passing light speed would definitely require some magic. I mentioned last week that the Parker Solar Probe in 2025 is going to become the fastest thing that humans have ever created, going at 430,000 miles an hour around the sun, and even to get to the closest star would take 6,700 years. At our current technology, the only way we're going to reach any other stars is through generation ships. This would be a ship where human beings are born, live out their lives, and die generation after generation after generation for as long as recorded human history has existed. And it would have to be maintained that entire time. Like, imagine if the first pharaoh of Egypt built a car, and we have to keep that car running. And we're living in the car. And you can't open the window if somebody farts. My metaphor is falling apart here. Life extension technology might be able to cut down on the extreme number of generations it would take to get there, but still, it wouldn't be you dancing on Proxima Centauri. It would be some long, distant descendant of yours who, after thousands of years of the extreme environment of space, speaks a completely different language, is probably a different race than you, maybe even a totally different species. So, good for them. Bummer for you. Fortunately for us, Arthur C. Clarke didn't just stop at one law. Number 3 is the famous one. There are 2 others. Clarke's law number 1. When a distinguished but elderly scientist states that something is possible, he's almost certainly right. When he states that something is impossible, he is very probably wrong. Distinguished but elderly scientists might disagree with that statement, but it's proven true in the past. We once thought that humans would never fly. We once thought that space travel was impossible. We once thought that nuclear power was impossible. Even Einstein thought so. Some of the founders of quantum physics thought that interpreting quantum measurements in reality in the real world was an exercise in futility. My point is, everything is impossible until it's not. Or as Clarke's second law says, the only way of discovering the limits of the possible is to venture a little way past them into the impossible. And that, I feel, is a law worth obeying. So hey, you guys have heard me talk about Nebula on this channel before. Maybe you've had a chance to check it out, maybe you haven't, but it's basically a streaming service that I'm a part of, as well as many of your other favorite educational YouTubers out there, and it's a place that operates outside of the YouTube algorithm, and they're sponsor free, so it allows us to kind of, do things that we can't normally do on YouTube. Like, if you feel like YouTube is choking the creativity out of YouTube channels these days, then yeah, that's exactly what this is for. So when you sign up for Nebula, you're not only getting a one-stop shop with all of your favorite YouTube smart people on there, you can watch them ad-free, and there's exclusive Nebula content that you can't get anywhere else. I'm actually working on a Nebula exclusive series right now. Tom Scott has one that's really great on there. He's a much smarter Scott than me. Plus, you're supporting literally dozens of YouTubers. For the same price as the lowest subscription on Patreon, you're literally supporting dozens of YouTubers. And in return, you get everything that I just talked about, plus CuriosityStream. CuriosityStream is partnered up with Nebula to offer a package deal, so that basically when you sign up for CuriosityStream, you get Nebula for free. CuriosityStream is of course the premier streaming service offering the best in educational documentaries on everything from space travel to history to art, biology, whatever it is that you nerd out on, it's there. If you like the topic of this video, you might like the series Speed that takes you through mankind's constant evolution from crossing oceans to continents to the skies to space, with a nice little bit about wormholes, which I didn't even get into in this video. But seriously, CuriosityStream is great. It was created by the same guys who created the Discovery Channel, so this is kind of what the Discovery Channel was supposed to be. Anyway, you get both Nebula and CuriosityStream for one price, which they're discounting right now at 26% for the yearly subscription, which brings it down to $14.79 for an entire year. It's like $1 and change a month. If that sounds good to you, just go to curiositystream.com/Joe Scott, or there's a link down in the description. And if you're tired of hearing me talk about this, then I suggest you go to curiositystream.com/Joe Scott and sign up for a Nebula subscription, because on Nebula, the videos are ad-free, so you wouldn't be hearing me talk about this anymore. Modern problems require modern solutions. Big thanks to CuriosityStream for supporting this video, and a huge shout out to the Answer Files on Patreon that are forming a nice community and being awesome and doing cool things. I love all of you. There's some new people whose names I gotta murder real quick. We got Chris Ferguson, David Pete, Ballet Bashu, William Holes, Andrew Hagan, Sally Jenko, Marco Pavlovic, No Pants Mode, love it, Nathan Marvey, Mike Myers, David Coleman, Otter Ruin, love that one, Joe Rudkowski, Eduardo Sadre Jr., Ekin Segic, Eric Roth, Trevor Eberil, and Andrew Spencer. That almost broke me. Thank you guys so much. If you would like to join them, get early access to videos, access to me, exclusive live streams, and other kinds of stuff, you can go to patreon.com/AnswersWithJoe. Please do like and share this video if you liked it, and if this is your first time here, this one is apparently up your alley. Google seems to think so anyway. There's also other videos down here that might have my face on it. You can go check those out. And if you enjoy them, I invite you to subscribe. I come back with videos every Monday. All right, that's it for now. You guys go out there, have an eye-opening rest of the week, stay safe, and I'll see you next Monday. Love you guys. Take care.